Okay, we're going to work on problem number 27. And we're going to notice where this function is discontinuous. If we could get this pen to operate. Okay. So this rational function, got to find where this denominator equals 0. So we're going to set x squared plus x minus 6 equals 0 because that's going to reveal the location of the vertical asymptotes. Now notice that this is factorable. Plus 3 minus 2. So by the zero product rule, we know x plus 3 equals 0. We know x minus 2 equals 0, and this tells us that x will be negative 3. And here, x will be positive 2. So here's our vertical asymptotes here. These are the values of x, right, that we cannot have. And notice y at x is negative 3. Looks like it's over here. You'll have vertical asymptotes. Then at x is positive 2, you'll have vertical asymptotes. So these are the locations of our vertical asymptotes. Okay, now this particular function, they're asking us to integrate over the interval from 0 to 4. So that's over here. And as you can see, we have a vertical asymptote not at an endpoint, but you have that vertical asymptote going through the interval at 2. So we have an improper integral because this function is discontinuous at a point in a closed and bounded interval. Okay, so I'm going to move all of this out of the way. And we're going to set up our integral here. So we're going to integrate from 0 to 2 of 1 over x squared plus x minus 6, and integrate from 2 to 4 of 1 over x squared plus x minus 6 dx. You're going to have two integrals. First improper integral, second improper integral. Okay, we're going to want to get, ladies and gentlemen, we're going to want to get convergence for both in order for this improper integral to converge. If we get divergence for one of them, whether it's the first one or the second one, well, then the whole integral diverges. So let's try this out. Let's see. A was integral from 0 to 2, 1 over x squared plus x minus 6 dx. And that is defined to be the limit as t goes to 0, as we integrate from 0 to t, 1 over x squared plus x minus 6. So let's take a look at this here and recall that this is the I of t. And once we find I of t, we take that limit as t goes to 2 from the left. So we made a mistake there, so we're going to fix that. T goes to 2 from the left. This is where we have our discontinuity, right? So we're going to let that be the T. Okay. And this is going to go to 2 from the left side. All right. So really, we're going to have to integrate here. This is the I of t. Okay, so we're going to have to integrate this here. So that integral is a rational function. Let's recall that we graphed this as our factored as x plus 3x minus 2. Now, the reason I'm writing down the factored version of the denominator is because we're going to use now partial fraction decomposition, PFD. Okay? So a partial fraction decomposition question here, really integral. So we're going to write this down here as 1 over x plus 3 times x minus 2, a over x plus 3 plus b over x minus 2. We get a x minus 2 plus b x plus 3 over x plus 3 times an x minus 2. So if we have equal fractions that have that same denominator here, like we've seen in the past, that implies that your numerators are the same. So what that implies is that 1 will be a x minus 2 plus b x plus 3. Okay, we're going to try to find those values of a and b, because you know we have these distinct linear terms. So if we let x be 2 now, wherever there's an x, we let it be 2, we get 1 equals really b times 5, which means b is 1/5. So we get this value here. B is 1/5. Okay. Now we're going to let x be -3. Right? Because when x is 2, we zeroed out this term. We're going to now let x be -3. And when we do that, this b term goes away. And you end up with 1 is -5a, or a will be -1/5. A is -1/5, right over here. B is +1/5. Okay, let's double check there. All right, so this integral, I'm going to write it as 1/5 over x minus 2 minus 1/5 over the x plus 3. As you guys know, I like putting that negative term second, starting, my fractions here with the positive value 1/5. So that means that's over x minus 2. Now that really becomes 1 over 5 x minus 2 minus 1 over 5 x plus 3. So we're supposed to integrate this, and that's the same as integrating what you see here. And of course that goes from 0 to t, I believe, right? Yes, it sure does. 0 to t. Okay, so by properties of integrals, if I want to put brackets there, we really have 1/5, the integral, 0 to t, 1 over x minus 2 dx, minus 1/5 integral 0 to t, 1 over x plus 3 dx. Okay, so we're going to integrate here. U sub. This is a nice U sub question, where u is x minus t. And it's really for both two u sub questions. In this case, u is x plus 3. So we got u substitution. This is 1/5 the natural log absolute value, x minus 2 minus 1/5 natural log absolute value x plus 3, evaluated from 0 to t. And, okay, I think we can simplify this a bit. This would be 1/5 natural log absolute value x minus 2 minus natural log absolute value x plus 3. 0 to t, we end up with 1/5 natural log absolute value x minus 2 over x plus 3. By using properties of natural log of a difference is the natural log of a quotient. So applying the limits now, natural log t minus 2 over t plus 3 minus 1/5 natural log 0 minus 2 over 0 plus 3. So we end up with 1/5 natural log absolute value t minus 2 over t plus 3 minus 1/5 natural log absolute value of, that should be negative 2/3, which is going to give you positive 2/3. So 1/5 natural log absolute value t minus 2 over t plus 3 minus 1/5 natural log of now positive 2/3, because the absolute value of negative 2/3 is positive 2/3. So here's our I of t. All right. Okay. So we're supposed to take that limit now. Take the limit of this as t goes to 2 from the left side. So as we try to take that limit as t goes to 2 from the left now, right? Let's see what we get. So by properties limits, here's what we end up with. Right? Limit of a difference is difference of limits. Limit of a constant, which is we're going to see out here. This is just a constant. We're going to need to find this limit. Okay. So what we need to know is this. As t goes to 2 from the left, the quotient of t minus 2 over t plus 3, this is going to go to 0. Okay? And going to 2 from the left means t is less than 2. Yeah, so it's actually negative values, but because, t is smaller than 2, like if you said 1.9, so that difference is negative and in the numerator, but the denominator is positive, right? So we're going to 0, but the values there are negative as they go to 0. However, you're looking at the absolute value now, which makes it positive. And so that's going to go to 0. Okay? What that means about the natural log function, as you go to 0, these positive values, this goes to negative infinity, because you know how the natural log curve looks. Okay? Natural log curve looks like this. So you're going to negative infinity here. So this limit is negative infinity. And, you know, a constant times negative infinity still is going to be that negative infinity. So you have this negative infinity minus minus the value of 1/5 natural log 2/3, which is still going to give you negative infinity. Okay? So that first improper integral is negative infinity here. Okay? The first improper integral diverges. So this is the divergent improper integral. And that kind of makes some sense if I said to you, look at this picture here. Okay? What it means is this area here is negative infinity. Now remember, you can never trust the aspect ratio of these graphing tools because they tinker with the scale. So that area to the left there for that first improper integral, we see it diverges, which means this whole integral diverges. We just say it diverges. So this one's not too bad either. But that's the whole situation. So this first one diverges. We don't have to check the second one at all. Okay, so there's the answer to number 27. I'm going to send this to you guys. I hope you enjoy the video. Thank you.